All right, this recording is going to talk about that worksheet that I sent out for 9.5. And I think this is important because logic meets math. We have to really think through, what does something mean? How do we take this quadratic formula and make it do something useful to us? And it's a very, very interesting application that I think is important, not necessarily because you have to find these intersections a lot in life, but because the thinking skills are really truly worth spending time on. So let me set it up for you again. We've talked about this before. If this part is solid, obviously you can skip through the recording on this part, but if it's not solid, then let's talk about it. So if you have a quadratic equation and you're solving for it, you want to know the values of x, then we solve this. So a quadratic equation is ax squared plus bx plus c equals 0. If you want to know when it's equal to 0, then you could solve it this way with a, b, and c for your values. When we do that, we have one of three options resulting. Any number, you'll agree with this, I'm sure, any number is either equal to 0, bigger than 0, or less than 0. So let's take the number that would be b squared minus 4ac, and let's say that that number is greater than 0. First case. First option. If that's true, then what I have is negative b plus or minus the square root of some number, whatever that number is, divided by 2a. Well, that could be rewritten as negative b plus a square root of a number over 2a, or negative b minus the square root of a number over 2a. We write this as one number. This plus minus sign that we use, we write it like it's one number, but what we mean by that is maybe you add it, maybe you subtract it. So this has two answers. Negative b plus something divided by 2a, and negative b minus something divided by 2a. That's the first scenario if that number is greater than 0. There's a second scenario. It's possible, in the second case, that b squared minus 4ac, whatever those numbers are, maybe that gives you 0 for an answer. In that case, I have negative b plus or minus the square root of 0 over 2a. Well, the square root of 0 is 0, so if you have a negative b and you add 0 or you subtract 0, really that's the same thing as just negative b over 2a. So that gives you one answer only. Your last option is if b squared minus 4ac is a negative number. It's less than 0. Well, in that case, I have a negative b plus or minus the square root of a negative number over 2a. Now that divides out into two numbers, kind of like that one does, but because I have a negative under the radical, that gives me a negative b plus I root something over 2a, or a negative b minus I root something over 2a. And so I have two solutions here, but these are two non-real solutions. In other words, they include imaginary numbers, or we might say two complex, I'm trying to write in too little of a space, sorry. This is complex solutions. And remember, a complex number is of the form a plus bi. So all of this little stuff is side notes talking about this. There. Okay, so those are the three options that we have. Now, how does that work with our problems? All right, let's make sure we apply that with the problems. We'll start with number 1. So in this case, I have an equation, y equals 2x plus k, y equals x squared minus 3. Just like if we have a linear equation, we solve this and make an equation, solve it. And if you think about having two lines, right, if y equals x plus 5 and y equals 2x minus 3, If we want to find the intersection of these two, one way to do that is substitution, and that's to say, well, y has a name and y has another name. If they're both the same thing as y, they must be the same thing as each other, and we could solve this. And if x equals 8, then that means that y equals 13. So if we were to graph both lines, and notice, of course, y equals 13 either way you do it, right? 8, 13 would be the point of intersection. So there's 8, 13. Whatever the two lines look like, I'm not going to take the time to actually graph them, but whatever the two lines look like, they would intersect there. Because I substituted this name for x, y, and this name for y, and put them equal to each other, and I solved to find the intersection. The problem is, this was nice. Wasn't this nice when I could solve this equation by simply subtracting x from both sides and adding 3 to both sides? Wasn't that lovely? But on this problem, when I do it, 2x plus k is equal to x squared minus 3. But when I solve this, I don't come up with lovely, beautiful, nifty little answer. I come up with a quadratic equation. Okay, so it's the same thing, but it comes up with a quadratic equation. Now, the interesting thing about this is I need to find the coefficients and the constant terms of my problem. Remember, a is equal to 1, the coefficient of the x squared term. B is equal to a negative 2, that's the coefficient of the x term. C is the constant. It looks odd, but it's two terms because I can't put k and 3 together. Whatever k is, I could make it one number, but right now I don't know k, that's my variable. Now, again, here's the point of this. I don't need to solve and get it equal to 0. Because what I'm trying to solve here is not what is the intersection point. If I did that, if I just solved the whole thing, negative b plus or minus the square root of b squared minus 4ac over 2a, if I solve that, that would give me the intersection points. But the problem is, when I put the number in for c, I'm going to have a variable. So I can't find the intersection points. I have a variable. I have too many variables here. Okay, so I can't find when they intersect because this number changes, right? Whether or not they intersect is going to depend on the value of k. So what do I need to do? The question doesn't ask me to find the intersection points. It asks me to solve for k so that I have two intersections. How do we know if there's two intersections? Well, that happens when b squared minus 4ac is a positive number, back from the page we started with. All right, so if b squared minus 4ac has to be positive so that I have two intersections, b squared is 4. Make sure I write it down correctly. b squared minus 4ac looks like that. When I solve that, I get 4 plus 4k plus 12 is greater than 0. 4k is greater than a negative 16. K is greater than a negative 4. So what we're saying is if I take a number bigger than negative 4 and I put it into this equation, or more correctly into this equation, that these two equations will touch twice. What do you think I'm going to suggest we do next? Let's put it into our calculator and solve it. I'm going to do that on the next page actually. On my calculator, here's another helpful thing. On the top box, on the top bar, there's a zoom in the middle. And if I hit zoom, a menu pops up. And number 5 says, see what exactly it says, z square. Now you may have a little bit of a different thing, but see if you have a zoom, see if you have a zoom square. Because your screen on your calculator is more rectangular than square, it's not quite that bad. But when you graph a circle, it's going to look more like an ellipse. If you use zoom square, even though your box is a rectangle, it's going to actually make your graph look more round. So if you do that, it'll help you see what we're doing a little bit. It's not humongously different, but it's a good idea, and you could see it that way. Okay, so you might want to do that. And then here's what I would certainly suggest. Put in your calculator y equals x squared minus 3. Put in your calculator y equals 2x plus, and then we're going to pause a second. We have said that we'll have two solutions if k is greater than -1. So I would do this 3 times. I would say the first time I would put k equals 0, 2k plus 0. 0 is certainly greater than -4, and so I expect to graph that and get two solutions. There'll be a parabola and there'll be a line, and the line will touch twice. Then I would recommend that you do it again and let k be equal to -4, because what we found is that -4 is our boundary. So then if you make this second graph 2k minus 4, that's our boundary. That's going to give us one solution. Now, the key here is that the slope doesn't change. It doesn't really matter. But the point is that you're going to get one solution. And the third thing you're going to graph is let k equal a -8, something less than -4. So when you put in 2k minus 8, you're going to get a line out here that has no solutions. Again, play around with it and understand and see what it does, so you can fully grasp what it is we're doing. You are looking for this value of k that when I put it in there, I could predict how many intersections I had. Based on the value of k, if k meets this criteria, you'll have 2 intersections. If it's on that very exact boundary, you'll have the 1 intersection. And if you make it less than -4 instead of greater than -4, it'll meet the other one of no solutions. That's number 1. Now I'm talking a lot. Hopefully it's helpful. Don't mean to be overwhelming with it. Sometimes the math gets a little bigger. This one has a little bit bigger math involved, but it's the same concept exactly. If you have two equations of a line and you're trying to solve for it, and you don't have something, you can just solve for a variable. In this case, I'm going to make y equal to kx minus 2. And I do that because if I have a value for y, if this is another name for y, I could put it in here. Now the problem is, now I have to square that. And it doesn't look fun, but it is possible. Again, I'm going to do what I often do with you guys and give you a skeleton. I won't show every step necessarily, but if you have any problem with it, I think you can break it down and see where I got all of this. Make sure you square by foiling the numbers. And then when I combine things together, notice here's an x squared term and here's an x squared term. It looks weird because it has a variable as a coefficient, but it's still an x squared term. This is an x term and this is an x term. And finally, this is my only constant. So when I rearranged these, I had 1 plus k squared times x squared plus a -4 minus 4k x plus 4 equals 0. That gives me my values of a and b and c for the quadratic formula. So a negative b squared minus 4ac is all I have to do. And in this problem, it specifically says they want no points of intersection. That happens when what's under the radical is negative. You have nothing in the real number system because it's in the complex number system or the imaginary number system. And so b squared minus 4ac, what is under the radical, must be negative. So now don't panic. It is not simple math, but it's math, college algebra kind of math. This, when you FOIL it and you work it down, will become a very lovely 32k is less than 0. Should I write one more step in here? 16 plus 32k plus 16k squared minus 16 minus 16k squared. And then notice that the 16s drop out and the 16k squareds, hooray, hooray, drop out. And I'm left with 32k less than 0. K is less than 0. So what that means is when I put this into my calculator, which I'm going to suggest that you do, we'll see it. Now, the problem is we have x squared equals 4x minus y squared. I want to put that into my calculator. That means that I have to start by getting y by itself. And to graph this into a calculator, you actually have to graph two things. Your first y is going to be the square root of 4x minus x squared. Your second y is going to be the negative square root of 4x minus x squared. These two together, this one and this one together, are required to graph this. Because if you take the square root of both sides to get y, you have to introduce the positive and negative values of that. That's how you make your calculator graph a circle. Your calculator is not very smart. It will only graph functions. If you want to graph a circle, that's not a function. It doesn't pass the vertical line test. So you've got to trick it into doing it by having it graph it twice, the positive value and the negative value of that square root. The third equation that you're going to graph is kx minus 2. I would suggest you do it 3 times. First, graph a negative value. It doesn't matter what value you choose, a negative kx or negative 5x minus 2, because if k is less than 0, we're expecting no solutions. So if you graph for your third y value a negative 5x minus 2, it's going to give you a circle and a line with no intersections. If you then say, well, what happens if it is equal to 0? Well, if it's 0, then you just have y equals negative 2, and that would be your boundary. That's going to have one solution. Okay, remember the green one had no solutions. And then lastly, if we do the y3 graph and I do greater than 0, so y3 is equal to maybe 5x minus 2. Notice the only thing you're changing is this k. Everything else stays the same. The y1 stays the same. The y2 stays the same. The y3 is going to have 3 different options. One option where k is less than 0. One option where k is equal to 0. Can't really highlight that. One where k is greater than 0. And you'll see you get no solution, one solution, and two solutions. Because this is your boundary point, okay? And on either side of your boundary, you get either two solutions or no solutions. On your boundary, you're going to get one solution. Last one, number 3. Hopefully by now it's making more sense. Maybe you're even trying it on your own before you watch this. See if you can get there. X plus ky equals 10. X squared plus y squared equals 10. And so once again, in this case, I don't want to divide by k. I don't want to mess with making a variable like that. So I'm just going to call x equal to 10 minus ky. So x squared is 10 minus ky squared plus y squared equals 10. When I square that and solve it, I get kind of crazy looking stuff. 100 minus 20 ky plus k squared y squared. Don't forget when you square that last term, it's k squared y squared plus y squared equals 10. When I put it all together, I get k squared plus 1 as the coefficient of y squared minus 20ky plus 90 equals 0. This problem asks me to find one intersection. If there's only one intersection, then that value must have been 0, because negative b plus or minus the square root of 0 over 2a is one answer. So then I have 400k squared minus 4 times k squared plus 1 times 90 equals 0, which works out to a very nice 40k squared minus 360 equals 0, which factors to be 40 times k squared minus 9, and that gives me solutions of k equals 3 and k equals negative 3. You can graph this and see how come I have two solutions. It's worth the time. Again, in order to make x squared plus y squared equals 10 into a graph, you're going to have to graph y squared equals 10 minus x squared, which means you're going to graph y equals y1 is the square root of 10 minus x squared. And always make sure you use your parentheses appropriately in the calculator. The second equation to graph that one function, well, it's not a function, is the negative of the same thing, square root of 10 minus x squared. And then, of course, the third one that you graph is just going to be 10 minus k times y. So you're going to let k be 3, and k be negative 3, and k be a few other numbers, and really start understanding on a deep level, what does it mean when I solve for k? What does that all look like? And notice how convenient it is to have something like the quadratic formula, so that even if you can't find the values, you can solve for k to know how it's going to work. Hopefully that's helpful, and certainly we can talk about it more in class if we need to. Thank you.